Hello everyone. So welcome back to the channel. Today we are going to do few more examples on Norrish type 1 reaction. Last we have discussed few examples, but that will not be enough for us. Okay, although you can practice lot more examples from Jagdamba Singh and Jaya Singh. Okay, the book I am following, but let's discuss few more examples. What will happen now? We have a system, right? Similarly, it will go to S1 inter-system crossing, it will go to T1, and then it is 0, and both the positions are alpha. Okay, so you can break any of the bond, there is no problem at all. So we have open like this, and then minus CO. All right, now a dialectical is formed. Okay, now one more step you can do, you can join the dialecticals. What do you get? You get two four-member fused rings. Okay, and four-member means more strained system. So this will not be formed. This will not be formed because four-member ring is very much strained. Okay. So you have a radical, and close to the radical you have a strained system. So this thing you need to remember, whenever you have a strained system or a pi bond, it will always help us in the stability of the radical, like this way. So instead of forming one more four-membered ring, this four-membered ring will be opened up. As a result, we will have a open cyclic system. Okay, we will have some open cyclic system. So this is more stable, and this will be the major product of the reaction. Okay, now discuss one more example of a very similar type. Okay, so very similar. So S1, sorry, light, S1, ISC, T1, and this is 0. This position is alpha, and this position is also alpha, like the previous one. It is very same. So what will happen? One of the alpha bond will be broken. Okay, you will get a diradical. Next step, minus CO, minus CO. All right, radical, radical. Okay, since we have a conjugated at both the positions, so it is expected that the two radicals were close to each other, because outside we have steric crowding, है ना? बाहर crowding होने की वजह से जो radical हैं वो close आ गए. Okay, close आने से क्या होगा? They will join together. They will join together. Okay, so this was the most expected product, but as I said earlier, this will not form. Why? Because यहाँ पे हमारे पास पाई सिस्टम है, और ये पाई सिस्टम क्या कर रहा है? इसको स्टेबलाइज होने में हेल्प कर रहा है. Okay, so as a result, what we will get? We will get a this type of system. So this will be the major product of the reaction. So I hope you have understand. Okay, if you have either a stain system or a pi bond, okay, adjacent to the radical, it will always help the radical to get a same molecule, to get the stable molecule, either opening up the ring, okay. So forming of ring will be our least priority in such cases, okay. Let's take one more example where you will understand this concept. This is another molecule we have. So what will happen? 0 alpha alpha. Now, previously we have two similar alpha positions. Okay, both are same. You can take any of the alpha position. But now, same S1, ISC, T1. So you have two options. Okay. In the very first option, you break this alpha bond, radical, okay, and or this alpha bond. Okay, so you can say that A alpha bond or B alpha bond. So we get two different intermediates. So although it's okay, now we leave minus you will get the same molecule. Okay, but it is very important कि आप molecule को सही तरीके से break करें. You always understand आपको molecule को break कहाँ से करना है. That means stability of free radical. So how you get this? So this one is your primary, okay? Because the radical is attached to only one carbon. Here the radical is attached to two carbon atoms. So this one is more stable, more favorable. So minus CO, right? And we have a radical at these positions. Okay? Now, because minus CO. So you have radical at this position, right? So this is formed. Now, you have option again, you can join the radical. You can join the diradical, okay? But this was not the product formed because though stained ring 3-member and 4-member ring, they were fused together. Very much stained system. So generally stained system nahi banega. So what will happen? 3-membered stained ring release its strain. That will be the driving force. तो आप खुद देखिए मैंने आपको बताया था रेडिकल्स के एडजस्टेंट पोजीशन पे we have a strained system. So this strained system release its strain. As a result, okay, this type of molecule will be formed. In simple words, sorry, we have bond at this position as well. So this as well. You can count from 1, 2, 3, 4, 5, 6. Okay. So you can redraw it 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, 6. Between 4 and 5 we have bond. Between 1 and 2 we have bond. At the second position I have a isopropyl. So this will be the final molecule. I hope you will get it what I want to say, okay, in this example. In another example, what we have a lactone system. What are lactones? Lactones are cyclic esters. Okay? And when you pass light S1, ISC, T1, so what will happen? The lactone ring breakdown like this way. So what we will have a this type of system. Okay? So now this hydrogen and this will go there and this will come here. So as a result, डबल बॉन्ड O हाइड्रोजन एक एल्डिहाइड बन गया है हाइड्रोजन सो 1 2 3 4 dicarbonyl compounds or 1 4 dialdehydes will be formed in such example. Okay, you need to remember whenever it is given to you, you have a reaction in methanol, and then what will happen? A very different type of reaction will observe. I have two such example, okay, where methanol is added to the system. Okay, initially what will happen? The ring will open up S1, ISC, T1, and then your ring will open up OMe, and then you have ethyl. All right, so you have one radical at this position, other radical at this position. So generally in presence of methanol, what will happen? This electron come here, this will go there, and okay, so I have made oxygen toward this side. So you have a this pair over this side, ethanol, O methyl, and when you have like MEOH, so you have OMe. So O methyl, and this is ethyl group. So you need to remember this whenever a photochemical reaction give in presence of methanol, so your ring will expand, your oxygen always come inside. Okay, and initially you have a 4-membered ring, but now you have a 5-membered ring which is comparatively more stable. Okay, and methanol occupy this position. Okay, that's how this molecule will be more stable. I have one more example of this type. Let's discuss this one. Now in this example, what we will observe, yes, S1, ISCT1. So what we'll observe? We will observe alpha cleavage first. Okay. So 0, alpha, alpha. Both are alpha positions, but this one, because this is the bridge as well, so this alpha will broken down. Double bond O, radical, radical. In the similar way, the ring will open up. Okay, so oxygen, this will be a closer, and we have a carbon group this side. And then again, when we add methanol, oxygen, O methyl, so this will be the final product of the reaction. Okay, I hope you understand these examples.